December 17, 1939. The sun sets over the harbor of Montevideo, Uruguay. A massive explosion rips through one of the most feared warships on the planet. She isn't sinking from enemy fire. She is dying by her own hand. And what she represented would haunt the Royal Navy for the rest of the war. Welcome back to History of World War II. Subscribe and hit the bell. The engineering secret behind this ship shouldn't have been possible. Picture yourself as a British merchant captain in the South Atlantic in late 1939. The war is only weeks old. You're commanding a freighter loaded with beef from Argentina, heading back to England. The cargo holds are full. Your crew of 40 men are going about their duties. The convoy system hasn't been fully organized yet. You're sailing alone across thousands of miles of empty ocean. The morning is clear. The sea is calm. A light breeze ripples the surface. You're standing on the bridge with a cup of tea, watching the horizon as you've done 1,000 times before. Everything seems routine. The wireless operator hasn't reported any submarine warnings. The weather looks good for the next few days. Then your lookout calls out, "Smoke on the horizon." A ship approaching from the southwest. At first, you're not worried. It could be another merchant heading the same direction. It could be a neutral vessel from South America. It could even be a Royal Navy cruiser on patrol, checking on your safety. But as the ship gets closer, your blood runs cold. You can see the outline now. A warship. But not just any warship. She has two massive triple turrets, one forward and one aft, housing guns that look far too big for a ship her size. She's flying no flag. She's moving fast. And she's heading directly toward you. You grab your binoculars with trembling hands. You focus on the approaching vessel. And then you see it. The distinctive silhouette, a tower mast. The configuration that every merchant captain in the Atlantic has been warned about. It's the Admiral Graf Spee. You have perhaps 20 minutes before she's in range. 20 minutes before those 11-inch guns can reduce your ship to scrap metal from a distance where you can't even see the shells coming. 20 minutes before you become another statistic in the commerce war. There is absolutely nothing you can do. This was the terror that the Graf Spee represented. A warship that shouldn't have existed. A vessel that violated international treaties while technically complying with them. A predator designed from the keel up for one purpose: to hunt down ships exactly like yours and destroy them. But how did Germany create such a weapon? How did they build a ship with battleship guns on a cruiser's hull? And why did she end her career not in glorious battle, but scuttled by her own crew in a neutral harbor? The answers reveal one of the most audacious engineering gambits in naval history. How did nobody stop them from building this? To understand the Graf Spee, you have to understand the world of 1919. World War I is over. The German High Seas Fleet, once the second most powerful navy on Earth, lies scuttled at the bottom of Scapa Flow. The victorious Allies gather at Versailles to ensure Germany can never threaten the seas again. The resulting treaty was designed to neuter the German military completely. Look at Articles 181 and 190. The new German Navy. The Kriegsmarine was allowed only a handful of antiquated pre-dreadnoughts. These were ships already obsolete when the war ended. Ships designed before the dreadnought revolution transformed naval warfare. They were slow. Their guns were small by modern standards. Their armor was inadequate against contemporary weapons. They were permitted only for coastal defense to protect German harbors and the Baltic coast. Nothing more. Submarines were forbidden entirely. The U-boats that had nearly starved Britain into submission during the Great War were explicitly banned. But the real constraint was the replacement clause. Germany could only replace those aging ships when they reached 20 years of age. And the replacements could not exceed 10,000 long tons standard displacement. Why 10,000 tons? In naval terms of the 1920s, 10,000 tons meant a cruiser. A heavy cruiser perhaps, but still just a cruiser. A proper battleship of that era pushed 30 to 35,000 tons. The Allied intent was unmistakable. Germany could build ships capable of patrolling the Baltic or showing the flag in foreign ports. But they were absolutely forbidden from building capital ships capable of standing in a battle line against Britain or France. The Allies wanted Germany to have a navy that could bark but never bite. For German naval planners, this was agonizing. They were a proud service with a distinguished tradition, now reduced to a glorified coast guard. The humiliation burned, but necessity, as they say, is the mother of invention. And desperation breeds creativity. Enter the Weimar Republic of the 1920s. While Germany's economy collapsed and hyperinflation destroyed the currency, a small group of naval engineers was quietly working on something extraordinary. They began looking at that 10,000-ton number not as a limit, but as a challenge. Not as a constraint, but as an opportunity to demonstrate German engineering superiority. The German Admiralty faced what seemed like an impossible mathematics problem. How do you fit battleship-grade firepower and decent armor onto a cruiser-sized hull without the ship instantly becoming top-heavy and capsizing? If they built a standard 10,000-ton cruiser, like the Washington Treaty cruisers of other nations, they would get 8-inch guns and thin armor. That wasn't good enough. Germany didn't want parity with enemy cruisers. They needed an asymmetric advantage. They needed a ship that could operate alone on the high seas, disrupt enemy supply lines, and destroy the very cruisers sent to hunt it down. This led to the strategic doctrine that would define the entire class. The ship had to be faster than anything stronger than it, and stronger than anything faster than it. If this is changing how you see naval history, hit that like button. To achieve this seemingly impossible goal, German designers had to save weight everywhere. Every kilogram mattered. Every ounce could mean the difference between a viable warship and an unbalanced failure. The first major innovation was welding. Up until this point, large warships were riveted together. Millions upon millions of steel rivets holding overlapping plates in place. Rivets are heavy. The overlapping steel plates required for riveting add enormous tonnage. The Germans decided to electrically weld the hulls of their new ships instead. This was risky technology at the time for vessels of this size. Welding on this scale had never been attempted on a major warship. Critics predicted the welds would crack under combat stress. They said the hulls would fail in heavy seas. The Germans pressed forward anyway. By welding the hull seams instead of riveting them, they created a lighter, smoother, and actually stronger unitary hull structure. This process alone saved an estimated 15% of hull weight compared to a traditional riveted ship of the same dimensions. That's hundreds of tons freed up for guns and armor. Hundreds of tons that would make the difference between a mediocre cruiser and something unprecedented. The second innovation was even more radical. Every other major navy in the world was using high-pressure steam turbines for propulsion. Boilers, heat, water. Steam turns turbines. Turbines turn propellers. The technology was reliable and powerful. It had propelled warships for decades. But steam plants are heavy. They consume enormous internal volume. And they are desperately thirsty for fuel. The Germans made a decision that shocked naval observers worldwide. They abandoned steam propulsion entirely. Instead, they equipped their new ships with massive MAN 9-cylinder double-acting two-stroke diesel engines. 8 of them, producing a combined 54,000 shaft horsepower. This was revolutionary. Diesel engines offered incredible fuel efficiency compared to steam. A typical steam-powered cruiser might have a range of 5,000 nautical miles before needing to refuel. The German diesels promised nearly 16,000 nautical miles at cruising speed. Think about what that meant for a commerce raider. A ship hunting merchants across the vast expanses of the Atlantic and Indian Oceans needs to stay at sea for months without returning to port. Every time she enters a friendly harbor, she risks detection. Every refueling rendezvous with a supply ship is a vulnerability. A diesel-powered raider with 16,000 miles of range could operate almost indefinitely. She could appear anywhere, strike without warning, vanish before enemy forces could concentrate against her. Furthermore, diesels could go from cold iron to full power almost instantly. A steamship needs hours to build up pressure in her boilers before she can get underway. If caught in harbor by an enemy attack, a steamship is a sitting duck, trapped until her boilers are ready. A diesel ship could fire up her engines and be moving within minutes. But there were trade-offs. The diesel engines were incredibly tall, requiring a higher armored deck, which raised the ship's center of gravity. They were hideously noisy. They created intense vibrations at high speeds that exhausted the crew and rattled sensitive optical equipment. Living aboard a Deutschland-class ship at flank speed was reportedly miserable. Despite the drawbacks, the weight savings and range advantages were simply too good to pass up. The design concept was finalized. The Germans called them Panzerschiff, armored ships. The British press would soon mock them as pocket battleships, a dismissive term suggesting they were cute little toys compared to the real giants of the Royal Navy. There was nothing cute about what these ships could do. Stay until the end. The final hours of the Graf Spee reveal the fatal flaw in the entire concept. 3 ships were built in this class. The Deutschland, later renamed Lutzow, the Admiral Scheer, and the final, most refined version, the Admiral Graf Spee, launched in 1934 and commissioned in 1936. While they looked similar, the Graf Spee benefited from lessons learned on her older sisters. She was slightly beamier for better stability. She carried heavier armor. She had a larger, more sophisticated tower mast housing improved fire control equipment. Let's get beneath her skin and examine what made the Graf Spee so dangerous. First, firepower. This is what terrified British naval planners. The Graf Spee carried 6 28-centimeter SKC 28 guns. That's 11 inches in imperial measurements. They were housed in 2 triple turrets, one forward designated Anton and one aft designated Bruno. To understand why this mattered, you need context. A standard heavy cruiser of that era carried 8-inch guns. An 8-inch armor-piercing shell weighed roughly 260 pounds. The Graf Spee's 11-inch shells weighed 660 pounds each. It wasn't just about size, it was about physics. The Graf Spee's main battery could hurl those massive shells over 36 kilometers. That's more than 22 miles. At such ranges, the curvature of the Earth meant the shells would be plunging down from above, where deck armor was thinnest. More critically, an 11-inch shell possesses enough kinetic energy to simply smash through the armor of any treaty cruiser in existence. At ranges where a cruiser's smaller 8-inch guns would merely bounce off the Graf Spee's belt armor, her 11-inch guns would be punching clean through her opponent's hull. This was the overmatch capability Germany had designed for. If a British county-class heavy cruiser attempted to engage the Graf Spee in a fair duel, she would be utterly outgunned. She could not close to effective range without being pounded to scrap. She could not stand off and trade blows because her shells would unpenetrate while the German shells would. The only option was to run, and the Graf Spee was fast enough to chase down most cruisers anyway. For closer range engagements and dealing with merchant ships that refused to stop, she carried a secondary battery of 8 15-centimeter guns in single mounts amidships. These were the equivalent of 6-inch guns, perfectly adequate for destroying unarmed freighters or finishing off damaged warships. And for the killing blow against larger targets, she carried 2 quadruple torpedo tube launchers mounted on her stern deck, armed with 53.3-centimeter torpedoes. Any heavy cruiser that somehow survived the guns would have to contend with a spread of torpedoes capable of breaking her back. This armament suite made the Graf Spee the heavyweight champion of the cruiser world. Now let's examine her protection. This is where the pocket battleship nickname becomes misleading. The Graf Spee was not a battleship. If she ever found herself trading salvos with a genuine capital ship carrying 15-inch guns, she would be torn apart. Her designers never intended her to fight such battles. Instead, they used an all-or-nothing approach to armor. Maximum protection was concentrated over vital spaces: the magazines that held her ammunition, the machinery spaces that housed her engines, the command facilities that controlled the ship. Everything else received relatively thin plating. Her main belt armor was angled and ranged from 100 millimeters thick over the machinery to roughly 80 millimeters elsewhere. Behind this belt ran a sloping protective deck about 40 millimeters thick, designed to catch shell splinters that penetrated the main belt. Her main gun turrets had formidable 140 millimeter faces. What did this mean in combat? She was largely immune to 6-inch cruiser fire at normal battle ranges. 6-inch shells would simply shatter against her belt. She could resist 8-inch fire if the angles were favorable, if the shells struck at oblique angles rather than perpendicular. But she remained vulnerable to plunging fire from extreme range, where shells would strike her thinner deck armor from above. And she was absolutely helpless against true capital ships with 14 or 15-inch batteries. Her armor was designed for a specific mission profile: win duels against cruisers, absorb moderate damage, and keep fighting long enough to destroy her opponents or escape. The diesel engines pushed her to a top speed of approximately 28.5 knots. This was the crucial strategic figure. That speed made her faster than almost every battleship in the French or British navies. Most battleships of that era struggled to reach 23 or 24 knots. Only a handful of battlecruisers like HMS Hood or Renown could catch her. For her age, the Graf Spee was remarkably high-tech. She was equipped with FUMO 39G radar, one of the first operational radar systems fitted to any warship. While primitive by later wartime standards, this gave her a significant advantage in low-visibility conditions or at night. She could detect targets or threats long before visual lookouts, allowing her to choose when and where to engage. So you have a ship with battleship guns, cruiser speed, global range, and cutting-edge sensors. The perfect commerce raider. But here's the question that every foreign naval attach was asking. If you add up the weight of those massive diesel engines, 6 11-inch guns with their turrets, and ammunition hoists 100 millimeters of armor plate, and everything else a warship needs to function that doesn't sound like 10,000 tons. It wasn't. How did Germany pull off the greatest deception in naval history? They lied. They lied brazenly. They lied repeatedly. They lied officially through diplomatic channels with straight faces and formal documentation. The Treaty of Versailles stipulated a standard displacement of 10,000 long tons. Standard displacement is a specific technical measurement, the weight of the ship fully equipped for war with crew, ammunition, provisions, and fresh water, but without fuel or reserve boiler feed water. Germany publicly declared the Deutschland class at exactly 10,000 tons. Official government statements, formal notifications to the League of Nations, diplomatic assurances to Britain and France. In reality, the Admiral Graf Spee's standard displacement was approximately 12,500 tons. Her full load displacement, when she was actually sailing into combat with her fuel tanks topped off, exceeded 16,000 tons. She was 60% over the treaty limit. Why didn't Britain and France stop them? Several factors aligned in Germany's favor. First, political exhaustion. The Allied naval powers were drained by World War I. Nobody wanted another arms race. Nobody wanted another war. Challenging Germany over treaty violations meant risking confrontation. It was easier to look the other way. Second, clever obfuscation. German officials were masters of bureaucratic misdirection. They manipulated weight calculations. They claimed the welded hulls saved far more tonnage than they actually did. They underreported engine weights. They played games with definitions of what counted toward displacement. When foreign naval attaches raised eyebrows at the size of the guns compared to the claimed tonnage, German officials would shrug and credit German engineering efficiency. superior metallurgy, advanced design techniques. The implication was clear. If British engineers couldn't figure out how to do it, that was a British problem. Third, strategic miscalculation. When the Deutschland-class designs first emerged, many British admirals dismissed them entirely. They predicted the diesels would prove unreliable. They thought the ships would be unstable gun platforms, rolling excessively in heavy seas. They called them shell magnets because their armor wasn't thick enough to resist serious punishment. By the time the Graf Spee was commissioned in 1936, Hitler had already renounced the Treaty of Versailles. The Anglo-German Naval Agreement of 1935 had essentially legalized German naval rearmament anyway. The mask was off. The cheating had worked long enough to get the ships built and into service. The true test came in 1939 when war finally erupted. Captain Hans Langsdorff took the Graf Spee to sea before hostilities even officially began, positioning her in the South Atlantic to begin commerce raiding the moment war was declared. Over the following months, she became the ghost of the South Atlantic. She sank 9 merchant ships totaling 50,000 gross register tons, freighters carrying grain, tankers carrying oil, cargo vessels loaded with raw materials destined for British factories, all of them sent to the bottom. Remarkably, Langsdorff conducted these operations with chivalry that seemed to belong to an earlier age. He evacuated merchant crews before sinking their vessels. He ensured they had lifeboats and provisions. He transferred prisoners to supply ships where they would be well treated. Not a single sailor aboard those captured ships was killed. In an age of total war, Langsdorff fought like a gentleman. But her success, impressive as it was, proved something even more valuable than the tonnage destroyed. The mere presence of the Graf Spee in the Atlantic forced the Royal Navy and French Navy to deploy massive forces hunting for her. 8 separate hunting groups were eventually organized. 4 aircraft carriers, 3 battle cruisers, nearly 20 cruisers, all dedicated to finding and destroying one ship. That is a staggering strategic diversion. One commerce raider, operating alone across thousands of miles of ocean, had tied up a significant fraction of Allied naval strength. Ships that could have been escorting convoys, hunting submarines, or blockading German ports were instead scattered across the Atlantic searching for a single, elusive predator. The pocket battleship concept was working exactly as designed. Then came the Battle of the River Plate. December 13, 1939. Dawn over the South Atlantic. The Graf Spee was hunting near the mouth of the River Plate, one of the busiest shipping lanes in the Southern Hemisphere. Merchant ships carrying grain, beef, and wool from Argentina and Uruguay passed through these waters constantly. It was rich hunting ground, the kind of target-rich environment the Graf Spee had been designed to exploit. Then the lookouts spotted smoke on the horizon. Captain Langsdorff initially believed he had found another convoy. More victims for his guns. He was wrong. The Graf Spee had encountered Force G, a British hunting group commanded by Commodore Henry Harwood. 3 cruisers, HMS Exeter, a heavy cruiser with 8-inch guns, and 2 light cruisers, Ajax and Achilles, each carrying 6-inch batteries. Harwood had been waiting for this moment. He had studied German commerce raiding tactics. He had predicted that a raider operating in the South Atlantic would eventually be drawn to the River Plate shipping lanes. He had positioned his force accordingly. On paper, the Graf Spee should have annihilated them. Tactically, she nearly did. Her 11-inch guns concentrated first on Exeter, the greatest threat. Within an hour, Exeter was a burning wreck. Both forward turrets knocked out. Fires raging throughout the ship. 61 men dead. She limped away from the battle, barely afloat, out of the fight entirely. The Graf Spee also damaged both light cruisers, knocking out gun turrets and killing crewmen. But the British employed superior tactics. Commodore Henry Harwood split his forces, forcing the Graf Spee to divide her fire between targets approaching from different directions, while her 11-inch shells devastated Exeter. The 2 light cruisers closed range and pounded the German ship with their smaller guns, Remember the armor specifications from earlier. 100 millimeters of belt armor, designed to stop cruiser shells from penetrating vital spaces. The armor worked. 6-inch shells couldn't reach the magazines or machinery. But armor doesn't cover everything. The sheer volume of fire from the British cruisers tore up the Graf Spee's superstructure. It destroyed her galleys where food was prepared. It wrecked her freshwater distillation plant. Most critically, it damaged her fuel processing system, leaving her with enough refined diesel for only about 1 day of steaming. She wasn't sinking, but she was a mission kill. She couldn't run. She couldn't sustain a long chase across the Atlantic. She couldn't fight her way through to a German port thousands of miles away. Captain Langsdorff made the decision to enter the neutral harbor of Montevideo to attempt repairs. Under international law, a belligerent warship could remain in a neutral port for only 72 hours before being interned. 72 hours was nowhere near enough time to repair the damage. And British naval intelligence was about to deliver the killing blow. The closest heavy British units, the aircraft carrier Ark Royal and battlecruiser Renown, were actually some 2,500 nautical miles away, far too distant to reach Montevideo before the Graf Spee's deadline expired. But British intelligence broadcast a series of signals on frequencies known to be monitored by German intelligence. These signals suggested that overwhelming reinforcements were concentrating just over the horizon. That if the Graf Spee attempted to break out, she would be met by battlecruisers and aircraft carriers and destroyed. It was a bluff. A brilliant, desperate bluff. Langsdorff believed it. He faced an impossible choice: attempt to break out and almost certainly be destroyed by the forces he believed were waiting, surrender his ship and crew to internment in Uruguay, or destroy his own vessel to prevent her from falling into enemy hands. German naval tradition offered only one acceptable answer. On December 17, 1939, Captain Hans Langsdorff ordered the Admiral Graf Spee scuttled in the outer harbor of Montevideo. Her crew of over 1,000 men was transferred to a German merchant ship. Essential equipment was removed. Demolition charges were placed in the magazines and machinery spaces. Thousands of spectators lined the waterfront to watch. Newsreel cameras captured the moment. The whole world was watching. And as the sun set over the River Plate, explosions tore through her hull. Fire and smoke billowed into the evening sky. The mighty pocket battleship, terror of the South Atlantic, settled into the shallow water and burned through the night. One of the most feared warships in the world destroyed herself rather than face a battle that, unknown to her captain, she might have survived. 3 days later, Captain Hans Langsdorff shot himself in a Buenos Aires hotel room. He was found lying on the old Imperial German naval ensign, the flag of the Kaiser's Navy, rather than the Nazi swastika. His final act was a statement about where his true loyalties lay. What does the Graf Spee's story tell us? Perhaps it's about the gap between design theory and combat reality. The pocket battleships were brilliant solutions to impossible constraints. They could outgun cruisers and outrun battleships. They could operate for months without support. They could appear anywhere on the world's oceans. But they weren't designed to absorb punishment from multiple opponents simultaneously. The all-or-nothing armor scheme worked in a 101 duel. It failed when 3 ships attacked from different directions, landing dozens of hits across every exposed surface. Perhaps it's about strategic versus tactical success. The Graf Spee won the Battle of the River Plate tactically. She destroyed 1 heavy cruiser and damaged 2 light cruisers while suffering no fatal damage herself. But she lost strategically. She was cornered, immobilized, and forced to destroy herself. 1 ship had tied up massive Allied resources for months. But in the end, the Allies only needed 3 cruisers to neutralize her. Perhaps it's about the limits of deception. Germany cheated the Treaty of Versailles brilliantly. They built ships 60% over the legal limit and convinced the world to look the other way. But the compromises required by that cheating, the armor that wasn't quite thick enough, the the displacement that couldn't be stretched any further. Those compromises proved fatal when the shooting started. Or perhaps it's simpler than any of that. The Admiral Graf Spee was a glass cannon, terrifyingly powerful, incredibly long-ranged, but brittle when cornered. She represented everything Germany hoped to achieve with limited resources and clever engineering. She also represented the limits of what clever engineering could accomplish against superior numbers and coordinated tactics. The pocket battleships remain fascinating studies in how naval architecture responds not just to waves and steel, but to treaties, politics, and the desperate need to overcome impossible odds. Germany took a 10,000-ton limit and turned it into a 16,000-ton terror of the seas. For a few months in 1939, the Admiral Graf Spee proved the concept could work. Then 3 cruisers and a British intelligence officer with a radio proved it couldn't work forever. The wreck of the Graf Spee still lies in the mud of Montevideo Harbor. Her main rangefinder was salvaged and stands in a museum in Uruguay. Occasional proposals to raise what remains generate controversy and fade away. What survives is the lesson. Innovation can overcome constraints. Engineering genius can achieve the seemingly impossible. A single well-designed warship can tie up entire fleets. But no ship, however brilliantly conceived, can overcome the fundamental mathematics of being outnumbered, outmaneuvered, and outthought. The Graf Spee proved that pocket battleships could terrorize the seas. The Battle of the River Plate proved they couldn't rule them. If this changed how you see history, watch what happened to the Luftwaffe after WW2 next. Same untold story, same hidden history. Like, subscribe, hit the bell. Thanks for watching History of World War II.